Isn't that true? It's about where people see. I saw one soon yesterday. I saw 5 this morning. Both said they would be here. Friday bad time. And that we're not letting them breakfast there. It's awful. Okay, it being 5 minutes after the starting time, folks should be back from lunch, and probably more folks will walk in, but we're going to get started.
Okay, so here is the usual note 12. Okay, you are supposed to have read this during registration. Everything going on in this room today is a contribution to the IETF. Simply put. the usual pointers to the materials, Jabber Room, Mythico, register the session, and few updates. Oops. So we have finally a new RFC concerning the Lisp DBT. Okay, yippee. Has been there for a while, so we solved all the issues, and now we have a new publication. Which means, by the way, that we are getting closer to publish the introduction document, which the DT closer, not yet. So there were a bunch of missing references. DDT was one. What is missing now is LispSec, which, by the way, is under review. Yeah. Yeah. Expert. Yeah. We will talk after this. I forgot. Luigi Joel, we are the chairs of the working group. Welcome. Vasim just entered, is our secretary, along with Padma here in the front. Exactly. So we have to talk about the Lisp security document, but we will move that along, and so we'll unblock also the introduction document. So we are, our fault, a little bit late with the signal-free multicast document because we passed the working group last document, but we actually get sloppy and we just pushed for the publication. Not yet for publication. We need a shepherd. I will do it the write-up. There is no problem, but we will soon push it to the ISG for publication. Okay, it's just things became a little bit late, but. And then we have a few new documents that are all the documents that you see with the purple dots, on which we as a working group will work on and finally hopefully publish them. Okay, there's the latest adoption. Now, as for the agenda bashing, we will start with a small update of Albert about these documents. Okay, we will skip the L2, L3 EID mobility presentation because finally there is no update. Okay, and we will try to have a remote participation with Reshat trying to present from Toronto, I guess, the young model. Okay, or the water, maybe. Yeah. Yeah. We should arrive tomorrow. We want to speak face to face with him, but for today he's not. Then Dino will give an update on the predictive RLOCs document, and then we move to the non-working group items. Dino will continue with the EID anonymity document. We have a presentation about vendor-specific LCAF, and Fred will give us at the end a presentation about PGP-based mobile routing system for aeronautical telecommunication networks. Okay. Anything to content for the agenda? Today we have a nice setup with a huge screen so the presenters can see their own slide just in the face instead of turning all the time there. No comments? Okay, let's start. Albert? Like. No?
Okay, so this is the changelog for RFC 6830Bs and 6830B. Next slide. So I will start from 6830Bs. which is the data plane. Since the last IETF, we have two iterations, so O2 and O3, and I will explain which are the changes on both iterations. So next slide, please. So we had all the IANA considerations on the data plane, but they were actually relating to messages which are in the control plane. So we pretty much took everything and moved it to the control plane, except the UDP ports, which are of course in the data plane, and they stay there. And then we also had a comment, I believe, from Damien that there was a mistake, and we changed the ICMP message from too big to unreachable fragmentation needed, which I believe is the right one for IP. So next slide. Then that's for the control plane. We had 4 iterations since last IETF. I'm going to discard again all the changes. So next slide. So first, this comment by Joel, we clarified. So now the control plane does, so SMR and airlock proving are part of the data plane, which means that the control plane does not offer these services. So if another data plane wants to use the Lisp control plane, they need to either implement those by themselves or use or reuse the existing data plane SMR and airlock proving mechanism. So we clarified that. That's a requirement for any data plane willing to use the control. Then we also changed the TID field, which is in the map register map notified. Now it is, instead of a 16-bit field, it's a 2 8-bit field, while the low 8-bit represents the PID, and the high 8-bit represents the algorithm which is used for encryption. Next slide. And then, since we moved all the IANA considerations from the data plane to the control plane, because they were actually pointing to control plane messages, this is how it is right now. So, the IANA consideration for the control plane, we have 4 types of messages. So first is the Lisp control plane type, which is map register, map notify, map request, map reply, and so on. So we removed the Lisp info request, which was not on the original RFC. Then type codes 9 to 15 to 14, they are not assigned, and they are up to IANA to assign them if needed. And then there is the Lisp shared extension message, which is an RFC 8113, which is now an IANA registry with the first come, first served policy. And this is to allocate subtypes for experimentation with new messages. Then we have the Lisp act and flag field, which allocating new ones means that you need to go through IETF review or ISG approval. Then we have the LCAF type codes, which now they are specification required. So this means that if you want to allocate a new LCAF, you have to write an spec. And then, since we changed the name of the field for KID, we changed the name for the registry. We requested IANA to change the name for the registry to Lisp algorithm ID number, which is first come first served policy if someone wants to allocate a new. So next slide. So this is how, just trying to summarize. So packet code types, 9 to 14 are IANA assigned, and then type 15 subtypes are first assigned by IANA, first come first served. Act and flag types are IETF review or ISG approval. LCAF is a specification required, and algorithm ID is again first come first served. So next slide. And this is 2 small changes that we are planning for the next version, which is the first one is changing all citations to 2460 with 8200, which is the new IPv6, the latest IPv6 spec, and then add a reference to the UDP checksum for RFC 6936, since this is the RFC recommending how to use zero UDP checksum in IPv6. So I guess that's a bit boring, but so that's it.
Any question on Coleman? May I state that we are converging to a stable cycle line? So I invite everybody to review the documents so that put out all the comments you have so that we move these forwards by Singapore.
This is Dino. Do you have recommendations on the ones that are currently about to be published? Should they point to the BIS documents or no? Let them move. And they point to 6830 and 60. Okay. Sounds good. And any, okay, so the problems I've had is any new internet drafts that want to point to something that's specific to this should point to these, right?
Yeah.
Okay.
Yes, new work we do should be pointing to these drafts, not to the existing ones. Rashad, you're online. Can you try talking so we can see if you can present remotely? Well, we have to unmute. Just a moment. We have to uncover the red button. The remote participants are now live. Rashad, can you speak? If we don't hear shortly, we will switch to the backup plan. I can tell that I can see that the mic is live on the tool. Oh well, can we do it? We'll do it local. Thank you.
So this is the update on the Young model draft. I think the best thing, I'm coming back from 3 weeks of vacation, so I'm kind of disconnected. So the best thing is that probably the detailed description will be done probably in the next meeting, or maybe the presentation will be posted in the mailing list, and I'll just give a very high-level overview of the update. So this version has addressed the change that were asked from the NMDA guidelines. So basically, you see here the major changes that have been included in this version. The upstate problem has been addressed. There is a new operational data store, and the last one is the metadata annotation that indicates the origin of the data in the operational data store. So I think this is an evolution that the young group of people is kind of pushing and asking, and this version is intended to kind of conform to those changes. So I think this is pretty much all I know, and we will post maybe the slides to the mailing list, and we can do another presentation for this meeting.
All the slides on the
They are
material.
already there, yeah.
So
Yeah, and if there is any specific questions, they can be addressed. Okay.
as you like, any comments or questions? No. That's clear. As usual, you want to.
Yeah.
Can you hear me in the back? Okay. So I'm going to talk about predictive outloads, which just became a working group document. The document status, we originally submitted it last spring, 2016. We updated the timer in November and also updated it again in May of this year, and we made it a working group document in June. Problem statement. So the mobility problem is pretty simple. When an EID moves, it just simply sends packets to a new location, right? Well, not really. Because packets that are already in the network are going to the old location where the EID no longer is. And the EID has arrived at the new location, but the signaling system doesn't know it's there yet. The packets, the sender doesn't know about the move yet, so packets are not moving yet, even though the EID is there. So you always have this problem where you're kind of in between. The move isn't atomic. So how do you solve the problem? So mobile IP, you really can't send to the home agent because it doesn't know where the location is. And you have to do that as quickly as possible. Host routes can tell you the location of what's being moved, but it requires the host route to be propagated throughout the network. And so handoffs are slow because the EID host route has to go everywhere. It has queuing delays, it has processing delays in the routing protocol. Locator ID separation can be used if signaling can be fast. So we tried to make signaling as fast as we can in Lisp in general, but we think we can make it go faster by not doing it. So what we want is we really want near zero packet loss. We really don't want to drop any packets, and we want these handoffs to be instantaneous. How do we do it? Well, the future can be somewhat clear if you know where all the new locations are going to be. So let's have a source send packets to all the new locations the roaming EID is going to be. We'll search and find where the EID has roamed to by getting feedback when it sends back. So we're exercising here a bandwidth signaling trade-off. We're not going to signal. We're going to use the data plane and bandwidth to find where the new location is. This is how it can work. So let's say we have these two EIDs, A and B. They're going down a road. Let's call the road Main Street. Let's say that Main Street is an EID that's registered to the mapping database with our lobes A, B, C, and D. Those are boxes that are along the street. Let's call them roadside units, like the IP wave people call it. They each have our lobes A, B, C, and D. Let's say EID points to Main Street, and so does EID B, which means they both can share this particular replication list. Note that Main Street is mapping to an RLOC record that's called RLE. That's replication list entry. And it basically has the 4 RLOCs there. So as the EIDA is sitting there at the beginning of the street, what we have is we see that A, B, and C are in a particular sequence. Let's say we have on the server side, XTRS is over there, and it's sourcing packets. And it has RLOC S. So what RLOC S would do when the server-side EID sources a packet is it will send the packets to all 4 places in the case where it's looking for EIDA. If the server is sending the EIDA, the packet's replicated to all 4 places. So what happens is the packet arrives at all the XTRs, and if the EID is discovered, the packet's forwarded by that XTR to the EID. So in this case, A sees that EIDA is attached to it, so it just forwards the packet. B, C, and D don't know that EIDA is attached to it, so it just drops the packets. Okay. In the case where B, the server sending to B, it notices that it's receiving packets back from it from B, so it can actually do a local optimization and not have to replicate packets to A, only to where it's at and where it's about to go to. Right? So we can have a pruning decision. Now, this is all done without any type of signaling whatsoever. The XTRS looks up Main Street, or looks up EID A or B, finds Main Street, has this replication list in its map cache A through D, and what it can do is just use a subset of that list when it's sending packets back. So there's no signaling whatsoever that's going on here. You have a question?
I just had a quick one, Dino. So the XTRs that don't have the mobile device located with them at the current time. When they drop the packets, do they send back a destination unreachable? Or is it
Absolutely not.
silent? Okay,
do
so
not.
it's silent.
It's silent,
Okay.
yes. They don't want to do that because if there's any action taken on that control plane and they move there, then they're going to have to signal to get the traffic to resume. And we don't want to signal. Signaling takes way too long for this requirement. So we think we can maybe even work for intersections. Okay, let's say we have this this street called Wall Street, which is basically an intersection between Main Street. And let's say that the Wall Street mapping entry is this distinguished name called Wall Street, and it has a nested RLE. So that means when the EID A starts off, we assume that it might be going straight. So you see A and B as the first element, or the first two elements in the RLE. And then you see at the bottom it C and D. The reason C and D are at the bottom is because if A goes straight, you want the replication to happen to A to B to C to D. Like that. But you don't know if A is going to turn left or right. You don't know if it's going to go northbound or southbound. So the next elements after B is RLOCs 1 and 2 if it's going to turn, RLOCs 1 and 3, excuse me, it's turning north, and 2 and 4 if it's turning south. Okay. So what could happen is when EID actually, the EID A moves to B, what it can do then now is replicate to the RLEs that are close to it, which means it could be B, 1, 2, and C, because you don't know if it's going to turn left, right, or go straight ahead. Okay. So these are things we could do by mixing and mixing and matching RLEs and nesting them. So what were the Lisp protocol changes required to make this happen? Actually, there were no protocol changes, no spec changes at all to the existing specs, because the RLE LCAP is already used for multicast head-end replication. We were just now using it for a unicast EID rather than a multicast S, G EID. And multicast will just work. The roaming EID, when the roaming EID is a receiver, it just IGMP reports, and then those guys just signal. But now they don't have to signal, because if you know where the EID is roaming and you know what groups it's going to join, you can just do this ahead of time. Now, when the roaming EID itself is a source for a multicast, it's the SEID, and it cannot be prefetched. I'll talk about prefetch in a minute. Actually, let me go back and tell you what prefetch means. Okay, so this comment down here, lower XDRs can prefetch RLOC-S. So when A is roaming down here and B, C, and D are getting packets, they're dropping packets on the floor. But there was a usefulness of this packet. It actually identified the source, EID. And what it can do now is look up that source, so it has a map cache entry. So when A comes to B, C, or D, and it wants to send a packet back to S, they're already prefetched, and you don't have to drop packets in the direction of client to server. So that's useful. Now, we don't have that documented yet in the spec, but that's the plan for the next spec, is to document that. Just go forward a little bit. Okay, so let's have a really quick demo. So let's say this 2.2.2 is a roaming EID, and you look at it, and you can see that it has 10.1, 2, and 3 as its replication list. So any roadside unit XTR will discover this 222 when it passes by it and starts sending some packets. There's the RLOC list, and then this is just some debug where now the server side 1.1.1 is sending to the roaming EID. The map cache is looked up. RLOCs in the RLE, and then this ITR basically replicates the same packet sent to 3 different places. And it's pretty much as simple as that. Plans for -01. We're considering, and we'd like to get feedback from the group about these. We want to have some RLE usage types. And let me explain the 4 types that we have. The directional one is the one I just explained. But let's say you have an RLE with A, B, C, and D in it. And the way it works for all usage types is that you would replicate to all 4 of them, and then you would solicit some feedback to prune or decide which one of A, B, C, or D you should replicate to next. So in the directional case, when you replicate to all of them, and then you see packets coming back from B, then you would only replicate to C and D. And that's what I showed in the previous slide, is that you basically prune A and B. This is without signaling. This just means the ITR has a list in its map cache of A, B, and C and D, but there's flags set that says it's only going to replicate to C and D. A and B is kept there because there might be a usage type where it may have to use A and B later. In the random usage case, when you send to all of them, but then when you get feedback only from one of them, you only replicate subsequent packets to that single one. And then after some short period of time, you go back to all of them. And then you react to where packets come back from. And that's because somebody may be hopping around between A, B, and C and D, and you really don't know where it is. Then we thought that there's probably some interesting usage cases where we might want to have something circular, which means if you go from A, B, C, D, when you get to D, then you start replicating again to A, B, C, and D again, just because you're going in a circular motion. Now, the EID may go from D to B. You don't know that, but you still replicate to A because you don't know if it's going to go to A next or to B next. Okay. And then the back and forth is similar to circular, but rather than going A, B, C, D, A, B, C, D, you go A, B, C, D, and then CBA, B, C, D, CBA, back and forth, we're calling it. So we're wondering if there's some good usage cases there where we could, so we're thinking in the random case or the back and forth case that maybe a roaming node on an E node B in a 5G network will go between 2 E node Bs back and forth or across 4, and we're thinking of using those sorts. Any, you want to add anything to that, Padma, or did I get? No, not okay. Okay, we did not document the prefetch that I just discussed, but we'll document that in -01. And that means when RSUs get packets from the initial replication, they do a lookup on the source EID to populate their map cache, so there are no packet drops when they appear on the new XTR. Other work, this is kind of researchy sort of work, but maybe can we do more things to prune that list? Because if the RLE list is going to be long, if there's roadside units every 1 kilometer and cars are going really fast, will we replicate too long? I mean, so we're looking at ways of, should we use multiple RLOC records, that's the 3rd bullet, and concatenate them, or should we use overlapping so we don't have to have these long RLE lists where we're replicating to more places than we need to? Okay. Can we use geoprefixes and see where the roaming EID is right now? The problem with using geoprefixes is when it changes its location, that location has to be reported with a control plane to some database. And if we have to look it up, it's defeating our purpose, right? If geocoordinates could be part of the data packet, then that's something that we could use, but there's no specification to do that yet. And we're not necessarily recommending that. Can we put RTRs close to the ETRs so the replication from the head end doesn't have to be N? Can we just replicate once, which is closer to Main Street, and then have it replicate there to minimize the head end replication problem? And can we use a level of indirection with distinguished names for grouping roaming EIDs to reduce the predictive RLOC? What I mean there is, in my example, we had both EID-A and EID-B point to Main Street, and Main Street had the RLE, rather than putting that same RLE in both A and B. So that was just a way of not having to duplicate the information in multiple mapping entries. And then could we use Lisp crypto? Well, we can use Lisp crypto by default, just like we specified it in the signal-free multicast case, where you encrypt with a different key to each head-end replication. And if you wanted to only encrypt once and replicate to many, you would need a shared key, which is not specified and is typically viewed as being not very secure, having shared keys. Not shared keys between 2 points, shared keys between more than 2 points. Questions, comments?
Victor Moreno. So the RLEs seem to have directionality in the examples you gave. How, if you're going on Main Street, east-west, and now you come in, same car, it's going to go back home. Any thoughts on how you can actually express that with your mapping requests and get basically an RLE that is going in the opposite direction?
Yeah, you could have two mappings for each direction, and then you have to decide which one to look up, or you look up both of them. Or you can use the circular. If you use this circular one or the back and forth usage type, then you can just put A, B, C, D in there and replicate all of them and find out where you first hear from it when it starts speaking. If you hear from a D, you know it's going west. If you hear from it from A, you know it's going east. Meaning it's sending packets with a source RLOC of D or A, so you know where it's starting. So there's all kinds of things we could do there, you know.
I just wanted to add something. Is that something else that we've been thinking about these RLOCs being actually added by a third party, which might actually also be having more information to what to add and what is useful. So that is something that we have been talking about. Is that necessary? It's not necessarily the EID point itself that's registering all the predictive
Absolutely.
location. It might be another party which is closer. Maybe, you know, I don't know. I'm just kind of going to say something.
Yeah,
else
I didn't-
here.
I didn't make it clear that who's registering the RLOC. I mean, you may have assumed just because you know how Lisp works that the EID or the XTRs themselves are doing it, but we very much thought it would be a third party doing it. Yeah. Thanks.
That makes sense. So another question, or basically probing for consideration. This would be extremely useful in a three-dimensional space, not necessarily linear space. Any thoughts on
I would say that my intersection case was three-dimensional, even though it was drawn on a two-dimensional slide. So you could have a plane that goes in the Z direction, and then you would have more nested RLEs that can, when you came over a certain direction, you'd have to send down here and down there, as well as there and there. So you could do it. Now, people have asked, can you use this in airplane applications where you don't know exactly where you're going? And what you can do is if you have some geospace where you know where the plane is, you just replicate everything in that space. So I don't know if you have any comments.
I was just going to say, but you mentioned it, regionality has something to do with it.
Yeah.
It could be that, you know, you pass through a radar system and they detect you and they say, you know, the next, 5 kilometers, you're not going to be changing. There is no other intersection. And
Air traffic control can be the SDN
yeah,
controller.
so
Yes. Okay.
there might be other ways. The way we're really looking at this is that third parties are other.
Yeah, thanks. So that interface is going to be key.
Yeah.
For us to be able to use it.
When I was pointing it, I was saying, Fred, do you have any comments on that space? Yeah. No, with respect to not knowing your direction precisely.
Can you come to the mic, please? Please. Yes.
It's Fred Templin from Boeing. So I don't see why it wouldn't work for a plane in flight that's taking a normal, civil aviation type of course. So, general aviation might be a little bit different because you can never tell where those planes are going. But certainly for airline flights, yeah.
Okay. Thanks.
There is always a flight plan that pilots have to hand in before actually take off.
Yeah.
Maybe if this information is somehow available,
Yep.
could be used.
It's when they deviate from the flight plan. And that's
and
when you need your data the
It's
most.
up to you to make it robust to these cases.
Another example that we use was trains. So these ones can't deviate. They're going to be on the same track.
Yeah, they're nailed into the ground. Yes, this is a good thing.
I had just one note on slide 14. You have there you say is random is when the EID is at B, replicate to B only.
Yeah.
That is random to me. I mean, you talk from B, so you send back to B.
What it meant was we replicate to A through D, and we don't know the direction that the EID is going in. If it was at A, we have a good opportunity that it's going to be at B next when we assume directionality. When it's random, it could be A, C, D, B, and it can come back from anywhere. That's what we meant. Padma, to add more.
What if you put unpredictable? I mean, I don't know.
Yeah.
Well, I would say random is almost the same as. Oh, you mean call it in a different name?
Yeah.
Oh, okay.
But
Yeah.
think about it.
No, that's a good
Yeah.
idea.
There's another interesting case about this is that even though we say we have a long list and you can replicate to all of them, because most of the time, even if we look at cellular phones or anything like that, they're actually handing over from one certain tower to the other. So at one point or another, you could restrict that to only the ones that are the real targets. So all this implies that you have, more machinery behind this, which is actually updating it. But this is very doable because they do have the information anyway. But I don't want to go specifically for that mobility case, but you can think about other cases where you might use third party with more information.
Padma, the way I would have implemented random is just because I got something from B doesn't mean I should just send it to B because it's about to leave B and it's going to go to one of the other three
Absolutely.
places. So the way I would implement it, I would send it to B and some random other one like A, C, or D, and just
You
define.
have another case there.
Yeah. Oh, yeah. Maybe, yeah. But don't forget, this is not where you send it. This is how you prune the list, right?
Okay.
That's what's really important. Yeah, okay.
I don't know if you want to call it temperamental because I'm very confused by it. Isn't this a case for Padma's comment on getting the information of what the behavior may be, where this is actually into not moving, and that's why you send to B?
If it's not going to be moving, why can't we just use regular mechanisms? You mean it's not going to move for a while, but
Because you may get information later that says, okay, now it's going to get ready to start.
we could use regular lists for that case, don't you think?
That's why I'm confused by random achievements.
Oh, okay. So he's saying why have random? We can use regular lists for that. Okay, maybe we should prune random or unpredictable from the list. Fine with me. Okay. Well, there was a requirement from somebody else, and they're not here to defend it. It doesn't make sense. Yeah, what I would say, if it's truly random or unpredictable, you should send to all of them and never prune the list because you don't know where it's going to come from. But anyways, we could do that too. But so it sounds like there's some input that maybe random is not useful or not understandable. We could certainly prune it. Hasn't been written up yet. So
Yes. I think in reality it's not so hard because think about what the Googles, the Facebook, the Amazons are doing. They just have data center based on geolocations. Also in the simple SNMP area, we are putting in geolocation information, GPS data into the SNMP strings to figure out where are the devices. On the other hand, all your mobile devices nowadays, they all have GPS implemented anyway. So I don't know if it's really hard, like with your, say, Python implementation, to pull the GPS information out of the GPS stack and put it into the list. And then I have GPS data to GPS data. So just move the routing stack from GPS to GPS and always have directions already. We are using this for our GPS navigation systems. So we know in a predictable way where the device is moving to.
Yes.
So if you move this up to the GPS stack, then it's really predictable at the end of the day. Because I know the geolocation of the devices.
But we need an IP address to encapsulate to. So how do we map that? If we have to put these geo things in the mapping database, we have to go get them. And sending a map request just takes too long.
Yeah, but
That's-
all our logs should have GPS data.
That's fine, but you got
Should just assume they have, because it's like with SNMP.
no.
So
I,
when SNMP
I agree 100%.
Okay, good.
But how does the ITR get the information when the EID moves from RLOC B to C? How does it know that? A physical move takes place.
Yes.
These parameters are updated in the mapping database. Now the ITR has to know to encapsulate to C. It's got to query the mapping database. That we're avoiding that whole process altogether because we are claiming it's too long.
I have to think about it. But I think it's, at the end of the day, it's
If you
fair
could
to
put the
assume-
GPS in the, if all those parameters, if A, B, and C and D can be programmed ahead of time, like we're specifying here,
Yes.
and this A, B, A in its geo coordinates, B its geo coordinates, as you're saying, then when somebody moves and the data packet's being sent in the opposite direction, if the geo point was put in the data packet, then we could recognize the geo points for the meeting. Therefore, we need to encapsulate that. But it turns out that packets that are going to be coming from the are already in the outer heaven, so we don't need the geo coordinates to help us here. It's really an IP problem, not a spatial problem or physical problem, right? Does it make sense? Yeah, okay.
would make sense to have a close implementation between the GPS stack and
Agreed.
the stack on a mobile device.
Yeah, yep.
Maybe your Python implementation.
Oh, yeah,
should
yeah.
be too hard.
Sure. Got it.
Just to add on what he's saying, the way I see it is if we had those alerts, which are those IP aggressive, but actually have a coverage of a certain range, then the geo coordinate has its sense. You can say, if you're out of this range of geo coordinates, you're going to move, and you know which direction you're moving, then you can actually use it and say, okay, probability.
And how does the ITR get the new geo points?
Here's the interesting thing. You just said earlier, if we replicate closer to their destination, that might be one way of looking at it. We have to think about that.
Okay.
Because the closer it is to their destination, the replication, you can actually maybe not have to go all the way back to the source to do the replication to the right one.
But you have to go to the mapping system, right?
Yeah, well, we'll have to think about that.
I think the missing piece to the solution is that the moving entity has to advertise directly to the replicator what its geoposition is. And if we can put it in a data packet that's part of the encapsulation, then it can work. But that's going to increase the header size. If you could send me a packet telling me where your geoposition is at this point as part of the encapsulation payload, then I know exactly that where you moved, right? And then I can use that information for something else.
Yeah, I'm thinking very, very strongly late binding here, so that's why
Got
I'm
it.
thinking.
Yes, but it has to be late and prefetched binding, right? It can't be
Make it
pull
more
based on
fun,
demand.
yeah.
Oh, okay.
If you go back to the old, say, mobile device world, how many encapsulation stays on top of this one? I really wouldn't care about this a little bit additional thing in the IP stack.
Okay,
Just
so
what
you're
you-
for it making the header larger. Okay.
Yes. It's a-
You get to convince the tens of millions of people. But agree. We should certainly try it out, right? Yeah.
Okay. Let's move to the next one, Tino again. Yeah.
So this is an individual submission about anonymous EIDs. Okay, so the document status here is, this was posted in April of last year as well. And in October, we did a timer update. And then in April of this year, we did an update to describe that ephemeral IDs can use public key hashes as well as a random number. We'll talk about that a little bit more. And we could also, we indicated that when the EID and RLOC are co-located, the XTR can register the EIDs earlier than if the EID was not attached to the RLOC, because the RLOC or the XTR would have to register when it receives a data packet, like the mechanisms in the EID mobility. Okay, what's the problem statement? How can we make EIDs private without enforcing payload encryption? How can we make EIDs untraceable? And how can we authenticate? Solution? Well, if a source creates an ephemeral EID and starts sending packets from them, that's how we can do it. In other words, a particular host doesn't have an EID that's permanent to it. It changes it over time. An ephemeral EID is going to be an IPv6 address. And the reason is to make it random enough or to carry hashes, you need enough bits in the address. So maybe part of the IPv6 address space that's used for ephemeral EIDs could be a random number, or part could be a crypto hash. And the source is free to create as many as it wants and to use them as long as it wants. And then the source can stop sending them and they are automatically deregistered from the mapping system. And the destinations don't have to do anything special to be able to process them. And typically, these ephemeral EIDs would be put on client hosts and not bounded to DNS names. So if I was a client accessing Google, the Google EID would obviously be registered in DNS, but I could change, for every connection I make to Google, I could change my EID. And of course, the XDR that's directly connected to me just discovers a new EID, registers the mapping system with its RLOG, so return traffic can come back. It's as simple as that. What were the Lisp protocol changes? None. All we had to do is just use the mechanisms in EID mobility. In the EID mobility draft, when an IP address comes and goes, the XTR just knows that it moved onto it. It doesn't know that it was a stationary node that has created a new EID. It's the same machinery that's being used. And so when the source stops sending from the ephemeral EID, it's just like when a source moves away from an XTR. It's a moved away event, so it can deregister as well. And then all traces of the EID are removed from the mapping system, and map caches in remote ITRs are invalidated. It's a pretty simple situation. So a really quick demo is, let's say this client is pinging an EID called DFDF:4:4. That's the server for Arlo. And what I did was I built a script. I have an XTR running on this system, but I built a script that actually creates a random EID. It basically pings the stationary EID. And it does that 10 times, and then it does another one. So what happened is I was running the EID mobility code, which was actually registering in, so the return packets could come back. Since you see ping replies, the return packets did come back. And then these are the old EIDs from previous runs. And that's pretty much it. This is not a working group document, and I don't know if you want to ask for it, but once I get off the to-do list, I'll ask for it, or see what you guys think. So what we need to do on our to-do list is we want to document ephemeral EID address collisions. So if the number of bits of the random number is small in a field, so you have enough hierarchy in the hierarchy of bits where you really don't have a long random number, there might be collisions, and what happens with collisions. So we're going to document that. If a client registers, or an XTR on behalf of a client registers an ephemeral EID that's already in the mapping database, the mapping database doesn't know if it's an RLOG change or a true duplicate. So we have to resolve that, and that's what we're going to document in the next revision. And that's basically a trade-off between the fields you use. To use a prefix field for policy or aggregation reasons, or how you split up the fields. And then let's look at crypto EIDs in more detail and how we can use them, and how practical are ephemeral IDs used with crypto IDs. The problem is that every time you change an ephemeral ID that has a hash in it, you have to change the key pair for the system. Is that practical? If you want the temporal aspects of the EID, does it make sense, and does it deserve the management of doing key pairing all the time? Because once you rekey a system, you have to make its public key available to other people that want to verify signatures or encrypt to you. So there's a bit of an overhead there. Okay, questions?
Yeah, this is Victor.
What triggers the change of the EID from one value to the next?
It's a policy in the source whenever it wants to. Maybe a source says, I want to use an EID per TCP connection. So every new TCP connection I establish, I'll go ahead and create a new ephemeral EID and then create the TCP connection based on that. And any TCP connection I terminate, then I stop using it. So whatever the source wants to do it. It doesn't have to be a Lisp-defined policy or decision.
So the actual bearers of the EIDs are the ones to
Yeah,
change.
which are typically can be source hosts or hosts are going to do it. Yeah.
Okay.
Hi, this is Albert. So you mentioned at the beginning of your slides that you were trying to authenticate the EID.
Yeah.
I guess this is related to the crypto EID.
Yes.
So I guess that the EID is a hash of the public key.
Yes.
And then how you demonstrate that you are actually the owner of the public private key. Meaning, okay, I hash my private key and I send you a packet. Then how do you know that actually?
Typically, the way that works, like in HIP, is you use the hash as a lookup to find the public key somewhere, and then you use the public key to verify a signature that's provided in the packet.
And do you plan to have this out of band, meaning out of Lisp, or within Lisp? All this process.
It can be done either way. We're working on a draft where we're describing how we could do it inside a Lisp. Yeah.
Have you thought about the implications on the cache? Because if you are a client and you said, I'm free to change my EID as I wish, basically. So which means that I install mappings in the cache locally and with my corresponding node on the other side. So either this can be used to attack the cache, or anyway there is a change. I mean, you overpopulate the cache. One guy is using more entries.
Yeah.
So this. Have you thought about that?
Yeah,
there is something in the document?
There is nothing in the. We've thought about it, but we haven't documented it because there's no great answer and text to do it. So we have to think of a way of writing it up. So yes, if somebody's really fast sending packets and allocating anonymous EIDs, it will fill up caches. All the rate limiting stuff in the mapping database still applies, but what it will typically, what we can do is on the guy so Victor is a co-author of the EID mobility. What we could think about is when somebody moves on to you as an XTR and you register these dynamic EIDs, the question is how many will you register per second? And so it might not be a mobility situation because the number of EIDs already exists, but they're just moving back and forth. I guess if 1 billion IoT devices move on to an XDR, this is a problem, which is no different than the comment you made, 1 billion ephemeral EIDs could be created in short time. So maybe we have to look at scaling problems in general on how to do this. I don't know if it should go in this draft or that draft or both, but it's something we need to work on. And since they're both working.
At least to be discussed.
Yeah,
I mean,
absolutely.
you have to mention this then solution, if there is a solution to be aware of that.
Okay, good
I
comment.
think,
We'll figure out where to document it. Thank you.
Fabio Maino. It's interesting. So I think one thing that could be interesting to look at if you haven't done it yet is consideration on the inference that the mapping system can do on anonymity. In the sense that if I am, so I guess that your trust model is, okay, if I don't have access to the mapping system, if I'm sitting outside, I see, this EID request going on, and EID mapping and registration going on, and there may be some inference that can be done because I see, the same EID registration coming from the same airlock. Sorry, a different EID registration coming from the same airlock, or something like that. So those, I think, are interesting aspects.
Meaning that's a bad thing, or there's something?
Well, it depends on what you want to do. In the sense that, for example, there are some solutions for anonymous routing, right? Like onion routing, that they go to a very long extent, right? And they try to use, different level of encryption to kind of prevent that anyone in the system can infer anything about the identity of the sender and the receiver. So those, I think, would be interesting consideration, right? And say, okay,
I'm trying to understand what your comment is. Are you trying to say that if the fact that these different EIDs are being registered by the same RLOC doesn't give you enough anonymity?
I'm saying that,
Okay.
the draft should kind of, so the way I see the draft is a draft that describes the use of ephemeral EIDs.
Yes.
Then the level of anonymity provided depends from, I guess, the way you use it and many other samples. So I think it would be interesting to sort of make a few considerations about that. So you can take an observer sitting outside of the mapping system, outside of the XDR, looking at the registration and what can he infer about that.
Got it.
And then you take the observer, you put it in the mapping system, and you say, okay, if it is in the mapping system, he can make another set of
inferences. Yeah. So, I mean, a solution, it's not an end all, but it helps. The problem is you could have a set of RLOCs on the XTR, a large set, and then the EID, the random EIDs could be encapsulated or supported by the different RLOCs,
Right.
and then you don't know if all those RLOCs are assigned to the same place or there's n different RLOCs or n different XTRs spread across the network, right?
Yeah.
So
Those
that would help. Okay.
Interesting consideration for the security section.
Got it. Okay. Thank you. Good comment.
Thank you.
So just to comment on what Fabio was mentioning. So we're going to assume that there is absolutely no correlation between the choice of an EID at post and wherever he's attaching.
True.
That makes everything really hard to
Yeah, it's purely a random number in the IP address. Okay. And the only thing that makes it attached to location is the source RLOC in the encapsulated packet. Right. Now, you don't know if there's, all you know is that there could be multiple EIDs behind it, and you don't know if they're separate systems or one system doing what's presented here. But if we could mash it up a little bit, it would be better. And certainly, Fabio's comment was at least have a discussion and acknowledge that this is a problem. Yeah. Sure.
No more questions, comments? Okay, thank you, Dino.
Do you want to make it a working group document? Or, I didn't put it on the slides, but I think Padley does, but I'm not sure. Do you want to make this a working group document? Do you want to make, we haven't requested this as a working group document. Do you want to? Yeah, yes. Was that too informal for you? No, you don't care. Okay.
I mean, you are the author, so you are asking to begin a working document, and nothing against. But
I'm not going to answer that question because I failed last time at it. So why don't you ask the group if they support it or not? Don't ask me. You don't know until you ask, I guess, right? And even if you ask, you don't know from the other guys.
did you think there are a bunch of
No, I don't think so. I mean, we have to have the security guys look at it and all the stuff that Fabio says. But I know people want, anonymity and addressing, so it's a feature that is desirable. Will they come and speak up at IETF versus the Lisp working group is another matter. Sure.
Okay, since the authors have firmly asked to adopt this document, so let's check what the room is. What's the sense in the room? So, yeah.
Okay, so all those who would speak up on the list in favor of adoption, if we sent such a call, please raise your hand right now. Okay, that's more than we've gotten on any of the recent calls. All those who think this would be a bad idea for us to adopt, please raise your hand. Okay, that's an indication it's probably worth issuing the call to adopt.
We will take it to the list.
Okay, so this is a draft Lisp vendor LCAP, Rodriguez Natal Lisp vendor LCAP version 0. So the motivation for this draft is very simple. While we have been implementing Lisp in various use cases, there are some metadata that we need to map that are kind of very specific to the use cases that we are deploying. And it's sure, you know, it's a relatively long process to define LCAP types for those, but the point is that some use cases are kind of very narrow, very specific to the application that we are implementing, and so it doesn't seem to make sense to have a public LCAP for that. So what we're proposing here is saying, well, okay, let's just define a vendor, a organizationally unique LCAP space, and we can basically use that private LCAP space within each organization. So if an organization has this kind of requirements, can define and use internally to that same organization that specific LCAP. And we avoid collisions across different vendors. So these things are very private, closed, and are used within one particular domain. A few applications, as I said, you know, the most urgent request that we see is for private deployment, but also, you know, experimentation and research or rapid prototyping is something that, you know, if you want to play within your own space of LCAP types, you can do it very, very easy. From the proposal and coding point of view, we leverage the OUI, the IEEE Organizational Unique Identifier. That is a 24-bit length, thanks to Joel that pointed us in that direction. And so in this way, we basically, you know, partition this little private space for each vendor. There is more than one OUI per organization, but two organizations don't have the same OUI. So that's the way we prevent collisions. The details, the internal details of the LCAP are left to each vendor, right? And for example, one vendor could decide to have his own internal partitioning to allocate, you know, the internal values. But this is on purpose left to the vendor itself. We propose to use the type number 255, and this has to be, you know, requested to IANA for allocation. And this is the, you know, the format very, very simple, right? It's basically saying type 255. We have 3 bytes for the OUI, and then the internal format that, you know, let's say is left to the private implementation. And I think, I don't know, Dino, do you have a question on this one?
Yeah, very quick. This is Dino. I don't know if it was documented. I think I forgot to comment. Is you have to make sure the OUI is from the IEEE list and not just any OUI, because there's virtualization companies that assign those values randomly.
Ah, okay.
So,
I think that
Those are not OUIs. They are
yeah.
they are 20-bit. But that's the point. Is it's not a field.
Yeah.
The OUI here is pointing to the IEEE register.
I think the draft refers to this one, to the standards OUI and the polyolog UI.
So somebody else called something else in OUI is not on that.
And yeah, and that's it. So yeah, any question, comment? It's very, very simple. The draft is super short and it's kind of trivial, right? In the sense the way you would organize this as practice.
Question or comment? If I read the second bullet, you want to go for
and
call?
the question is, since this is, kind of trivial and yeah, I think it would make sense to call positively about it if the working group agrees.
Okay, let's check. So, as the authors request, let's see if there is support to adopt this document as a working group item. So, if you agree to adopt this short document as a working group item, please hum now. Thank you. If you are against adopting this document because you think it's not worth it or whatever reason, please hum now. Silence. Okay, let's take it to the list. Seems to go in the direction of an adoption.
It's interesting that I will provide.
We know who raised their hands before. We saw you. Which brings us to the last presentation, which is Fred.
I'm Fred Templin. I work for Boeing. I've been attending a standards body known as the International Civil Aviation Organization Working Group I. And at Working Group I, we're talking about an IPv6 network for civil aviation for the future of manned aviation. So this is where I'm coming from the perspective of what's known as the Aeronautical Telecommunications Network, or the ATN IPS as it's called. So again, the International Civil Aviation Organization is building an IP-based network system for worldwide air traffic management. They're deploying something that's called Aeronautical Telecommunications Network with Internet Protocol Services, or ATN IPS. It's under development of ICAO Working Group I. It's IPv6 based and mobility capable. And it's going to accommodate aircraft that have multiple available data links. Aircraft typically have many data links on board. Satellite links, LDAX is an L-band cell tower based service, VHF data links, and others. So we're looking at three different candidate solutions for mobility right now. Proxy Mobile IP version 6 is one of the candidates. Something that's called ground-based Lisp is another candidate. And then there's also a BGP-based overlay system, which is the subject of this document. Now, BGP and Lisp, I know, interact, and I'll get into that later. So it's not like BGP is different from Lisp. It might be including Lisp. So I've written a document called a simple BGP-based mobile routing system for aeronautical telecommunications network. It's a BGP overlay network that does not interact with the global public internet BGP routing system. It's based on a hub and spokes arrangement with stub autonomous system border routers and the data link provider subnetworks, and core autonomous system border routers in the core of the network. The stub autonomous system border routers advertise and withdraw airplane mobile network prefixes. This would be the same thing as an EID prefix, to use the Lisp terminology. The core autonomous system border routers and a hub autonomous system forward packets between the stub autonomous system border routers. And route optimization can remove the core autonomous system border routers from the path. So how it looks like is that you have these EID-based subnetworks that the airplanes connect to, like these things here, and also air traffic controllers connect to. Then you have the stub autonomous systems with stub autonomous system border routers on the spokes and core autonomous system border routers in the core. That would be the core. And BGP is used between the stub autonomous system border routers and the core. And within the core, IBGP is used between those core routers. So the details of the BGP system is that stub autonomous system border routers advertise their associated EID-based mobile network prefixes to the core autonomous system border routers. The core autonomous system border routers originate default, but they did not advertise any MNPs to the stub autonomous system border routers. And also, each stub autonomous system stub subnetwork is assigned a MED value. The core autonomous system routers disable the AS path selection method and select routes based on the MED values. And that means that packets may take a longer path in order to reach a stub network with a lower MED value. So the reason for this MED value is that some data links are preferred over others. For example, airplanes should use SATCOM as a first alternative and fail over to other data links when SATCOM is not available. So the system ensures that there will always be a working route, even if it's only a default route. I've got a working network model of this I could demonstrate if anybody is interested. I'm not going to show the demonstration right now, but we can do that afterwards if anybody wants to. So how does this route optimization work? You have a source autonomous system border router. You've got a core autonomous system border router that we're calling the router in this diagram, and a target stub autonomous system border router. So the source is initially going to be sending packets via the core router to the target router. While the data packets are flowing, the source will get notified that there's a better first hop for it to use. The source then does what's known as a route optimization exchange with the target, and then future data packets can go directly from the source to the target. So this is a little bit different than what's happening in Lisp by my read of Lisp, in that if you think of the source as being the ITR and the target as being the ETR, normally what happens is that the ITR holds the data packet and then does a mapping table lookup to discover the RLOC of the target, and then starts sending the data packets to the target. So the difference here is that data packets continue to flow even if they're going through a less optimal route until the route optimization can happen. And this is where the document is located. I presented it at Working Group I Mobility Subgroup meeting back in May when I was in Montreal. The ICAO meetings happen in Montreal about 3 to 4 times annually. And there seems to be some interest in this approach in ICAO. So that's all I had.
Question, comments?
The data plane is encapsulation of IPv6 over IPv6. Well, it could use the Lisp encapsulation. It could use any encapsulation format. Okay, so where this came from is a proposal that I've been working on for a long time called Arrow. And Arrow uses what's known as generic UDP encapsulation, or GUE. But Arrow could just as easily use the Lisp UDP encapsulation. But the encapsulation format's kind of, agnostic. So.
Well, I have a question. I saw that you said that you don't really. Do you care about routing optimization, or you don't care about routing optimization? I know you mentioned that the packets were very important and they shouldn't ever be dropped.
Right.
But by actually sending it on a not optimized route, you're not sure either that it's going to make it back, right? Because you might have circular routing and then a loop or something. You don't really know either, right?
Well, in a stable state, your BGP peerings between those core autonomous system border routers are being maintained by TCP keep alives. So you've got a pretty good assurance that those links are up. And so if the packets take the suboptimal route through that core ASBRs, you've got the TCP keep alives that are there to maintain your links. And if a link goes down, then BGP is going to reroute, and it'll go over a path that has stable paths. We're worried about initial packet loss. because these packets could be the last thing an airplane ever sends. You know, the airplane sends a position report, or it sends a an intent message to the air traffic controller, and that packet we care about getting delivered. Well, no, the TCP connections have been up since the beginning of the network. This is the core autonomous system border routers are using BGP, internal BGP. Well, the thing about Lisp is that the packets, well, okay, the thing about what I understand as being the standard Lisp is that the ITR holds on to the packet until it gets a map reply back, right? And then it sends the packet. Well, a couple things can happen. First of all, when it gets the map reply back, it can't know without testing it first that the path from the ITR to the ETR is a working path. It knows that the path from the ETR to the ITR works, but it can't know that the forward path from the ITR to the ETR is going to work.
Yes, but you said the application is that the TCP connections will be up ahead of time.
Yeah.
Therefore, those packet drops happened on SYN packets. That's going to happen way before the data is going to need to be. That's what I'm trying to say.
I think I may be misstating that, you know, because the TCP connections are only inside of those core BGP routers. They're not. There's the TCP. They don't go out to the airplanes. The airplanes don't do the TCP connections. This is only in the core of the network.
But are they set up ahead of time?
Well, yeah, the same as BGP peerings. They're just normal BGP peering sessions.
Those are TCP connections for BGP, is what you're saying.
Yeah, that's right. Yeah.
Okay. And your question?
The reason why I was asking this is that you actually are relying on the BGP TCP mechanism to ensure that your packet makes it. Not really, but the moment you're sending the packets down from the plane, you have no guarantee that this is even up. You don't know that, right?
Well, the stability of BGP is going to be based on the fact that your autonomous system border routers aren't moving, and when you have an EID prefix comes onto a XTR for the first time, that XTR has to inject the prefix into the BGP routing system. So until that the EID prefix then gets propagated to the core autonomous system border routers, but doesn't get propagated out to the stub autonomous system border routers.
Yeah.
So there's very few nodes that need to get updated when a new EID comes into the system.
Yeah, coming from OSPF, when I read it the first time, I thought this looks exactly like OSPF with the backbone and the stub routes, stub areas that look exactly the same. What I was trying to say is that you're relying on some other mechanism down which doesn't have any connection with you. So, yes, these connections may go down as well. You have no guarantee of that.
Right, and it's the same thing that happens in any BGP network. When a connection goes down, you find a different path. Yeah.
Hi, this is Albert. Can you go back like 2 slides on the route optimization? Yeah.
You want to see the whole thing?
It is actually the blue line. Which protocol do you use to tell to the source that there is a better path?
Okay, so with the Arrow proposal, Arrow is based on a NDMA link model, which means you can use IPv6 neighbor discovery. So the neighbor discovery messages that happen are first, you get a redirect message. And after the redirect message, the source sends a neighbor solicitation and gets a neighbor advertisement message back. So that neighbor solicitation advertisement tests the forward path, so that before you start sending data packets directly from source to target, you know that the forward path is working.
Okay, so just a small comment regarding the previous discussion. What we do in OOR to prevent packet loss for the first packet before you populate the map cache is we send it to the proxy API, which is at the end equivalent to the router in your slide.
Yeah.
We assume that it has all the information. And then you populate the map cache and then you go direct to the
Right. This in the model I'm looking at, this guy right here has to have full topology knowledge of where all the EIDs are. So it's a default router. Yeah.
what is the process that ICAO will follow for standardization? You say that there are three proposals.
Yeah, so ICAO has this working group I, which is developing a document called DO, no, it's not DO, I'm sorry, it's 9896, ICAO document 9896, that describes the ATN IPS, the IPv6 application for the Aeronautical Telecommunications Network. ICAO has formed a subgroup called the Mobility Subgroup of Working Group I, and we meet on a 3 times annual basis, but they're also starting to hold interim meetings too that I'm participating in. They want to work towards a solution adoption within this year if they can. So we're continuing to work with some of the folks from the FAA and also Eurocontrol, which is the European equivalent of FAA. Airbus is involved. Inmarsat, which does the satellite systems, is involved. So you get a lot of people from the aviation community involved in this.
Might be interesting maybe for this group also to hear from, there was a proposal called ground-based Lisp.
Ground-based Lisp, yeah.
Maybe to have them at the next meeting or something.
That's not good.
Yeah, no, I mean, just talking to the working group.
We can try to reach out for them.
I was about to say what ground-based Lisp is, yeah. So with ground-based Lisp, the ground-based piece of it is that Lisp does not run on the airplanes. It only runs, the XTRs are those ground domain routers. So the airplane doesn't get to select which data link it's going to be used. The ground-based routers get to make that selection process.
And even in your case, there is no, so those routers, they are not on the airplane, right?
Right, that's on the ground, yeah. And this cloud here would be like the air navigation service provider network, like Iridium provides a ground-based network. And this out here, that would be the physical data link itself.
I just wonder what prevents us from having a real Lisp-enabled router on the aircraft. Because going some years back, we started with working with airlines on this. The only showstopper was that someone has to provide a certified and aircraft certified router to the aircraft. So I think you're in the business. It's like, isn't it just easier to have a Lisp-enabled router sitting in the aircraft? Then you can select all the different links, use Wi-Fi if you're on the gates, use the different VHF, whatever technologies, if you have a real router on the aircraft.
Yeah, that's what we call client Lisp. And client Lisp would be able to see all of the different aviation data links. So you might have a cellular system, you might have a satellite system, you might have a VHF system.
Right.
There are reasons why the community is going away from that. They want to have as simple a solution on the airplane as possible and one that doesn't require software upgrades. And so they want this thing to look like just an IPv6 end system. Even though the airplane has a mobile network on board, though, it has an EID prefix, not just a singleton EID address. But it's standard IPv6 routing. It doesn't have any requirement for there being a host application.
I don't want us getting in the business of trying to second guess ICAO Group I. I mean, we've got enough problems ourselves.
Yeah.
Thank you. So thanks for presenting this, Fred. Any thoughts on mobility? Are you adding mobility semantics to BGP as part of your proposal?
So the way mobility would work is that if you have mobility within a subnetwork, like I go from a first cell tower to a second cell tower, it's just like the way our AT&T wireless works. The service provider takes care of mobility within that subnetwork. So it's like layer 2 mobility and that standpoint. So the layer 2 mobility events don't get propagated into the BGP. But if you have an airplane moving from a first ITR to a second ITR, then that information does get propagated into the BGP. So micro mobility, macro mobility, if you will.
So for the macro mobility, are you proposing community attributes to BGP or how?
So again, it's the same way that cellular service providers do your mobility internally within their network. So I'm continually moving from cell tower to cell tower, but the cell service provider takes care of it at layer 2.
No, he's asking
I'm
for the
asking
macro.
Oh, I'm sorry.
I assume the macro was between.
Yeah.
Between.
Like if this
Yes.
airplane,
Yeah.
From exactly. Yeah. Yeah. What happens then is you have a BGP withdraw from the first BGP router and a BGP advertise from the second.
Now, there's nothing special for mobility.
Right.
How do you know you don't have two routes versus a better, newer route that needs to be withdrawn? That's my question. In EVPN, they solve that with community attribute. Not sure if you're using the same.
So with, taking an example of this airplane right here has two BGP routers it's associated with. So there's two BGP routes that are in the routing system, and the MED value determines which one gets used. And if the airplane goes away from one of those ITRs, the ITR withdraws the route, and BGP will take that route out of the rib.
There's no community.
Right.
Okay. Just based on pressing and maps.
Yeah. So. Well, so that's a good question for the ground-based Lisp guys, because it's the same thing with it is because with the ground-based Lisp, what you'd be doing is updating the mapping database. And I know the ground-based Lisp guys have thought about this. There's a company in Austria called Frequentis. You might have heard of Frequentis, and that's where a lot of these ideas have come from. The ground-based Lisp ideas have come from.
So my understanding is that the subnetwork has some sort of interface to the routers. Frequentis is simulating that gray network with OSPF, I think, right now.
Yeah.
So you will get an OSPF feed, and then if the routes are no longer there, that indicates it.
There's an adjacency.
Yeah.
There's just some form of adjacency.
There's an
that goes
adjacency,
down.
and if the route's no longer there, you then conclude.
I was
that
doing
it's
it
wrong.
at the BFU
The,
to make it fast.
the
That's not his problem.
right. The Frequentis guys always say that OSPF is used only as an example,
Yes.
and that the routing that's used within those gray subnetworks can be whatever happens to work for that subnetwork, whether it's OSPF or some other IGP or something different than an IGP.
And my comment to them has been, it would be interesting to see if there's an opportunity to standardize that handle so that whether we do it with BGP or Lisp, we have a standard way of actually seeing that, or one way of seeing that a plane is there or not.
Yeah.
Because otherwise, we're going to have to create connectors for each type of subnetwork. And I don't know, it's finite, but it's still a lot.
Each subnetwork, whether it be a satellite subnetwork or an LDAX or a VHF, should do the same injections and withdrawals in BGP. They shouldn't look different based on the different subnetworks.
Ideally, but when you look at Marsat's framing, it's pretty generous. It's nowhere near you see normal.
Yeah.
So
But a lot of this has to do with the sensitivities for the way radio protocols are designed, and
right.
that's not.
Yeah, it's not within scope.
Please.
Thanks.
I have another question. Is that I remember when I read your documents, you actually had, the call sign of the plane as the ID, as the network.
Yeah.
Correct. And I'm wondering how this is going to work, because you won't be able to aggregate this as you move from one place to the other, because each one of those airplanes are going to be roaming differently.
Yeah.
Have you thought about this? Because that is a notion that you'll have to. That's going to be a lot of traffic, because you won't be able to aggregate any of those, right?
Well, yeah. So just to give a little bit more background on that. So what we're saying is that the airplanes are going to get an IPv6 prefix that comes from the concatenation of a 24-bit ICAO prefix and the 24-bit ID of the airplane. So each airplane is going to get a /56 prefix, but you may never get any aggregation among the airplanes that are in a subnetwork. They may all have their own prefixes that don't aggregate along any lines. So each airplane's prefix is going to be injected into the IBGP. Now, I've done some emulation experiments that show that a single BGP router can handle 1 million routes. And there's not going to be 1 million airplanes in the sky at any time in the near future. There's tens of thousands of airplanes in operation at any time. So 1 million is already a pretty good, reasonable scaling, upper level. So
My question stems from, the convergence time of BGP. I'm an IGP person, so disclaimer, when I look at BGP, I always feel that this is much longer, especially if you're talking about a packet that should not be dropped, that's going to be retained, and it has to be done. If you have 10,000 planes and they're sending each 1,000 packets before they die, and you're converging, I feel,
But-
you need to do some simulations here because
Yeah.
it doesn't look slam dunk to me.
Well, the one thing I'll say about that is that the number of these core ASBRs here is on the order of tens. It's not on the order of thousands or hundreds of thousands. So there's not a lot of convergence time to get those things to converge. And the stub autonomous system border routers, these guys here, there can be thousands and thousands of those, but they don't keep a full routing table. They only keep default, and they only maintain the default that points to one of their core autonomous system border routers. So they only know about their associated airplanes and a default core autonomous system border router.
This is why this reminds me strangely of OSPF, where everybody knows I've been spending a lot of time in OSPF. Because
Actually,
this
it
looks
goes
a
back
lot
to
like
EGP.
default
I mean-
and, yeah.
But it's a very constrained environment. They are designing it for a specific purpose.
Yeah, yeah. That's well, you're careful. Yeah. Right. No, it's the latter. But be careful that this is not necessarily the IPv6 addresses that'll be given to the passengers. This is for air traffic control. So this is for the pilots to talk to. So I don't know if this is answering your question, but the airplane is going to have potentially an Internet of Things set of addressable devices on board. The air traffic controller might want to address the pilot. It might want to address the aviation actuators. It might want to address the engines. They're all going to have IPv6 addresses.
But that's all using the same prefix.
Yes, all using the same prefix.
That's the point. That's
One prefix.
The numbers of prefixes you have is quite tractable.
Yes, yes. Yeah, you would hope so.
We're moving separately. We're in a different domain.
Yeah. Yeah. Exactly. Exactly. Yeah.
That's quite tractable. Half a dozen databases behind that.
Quick question, Fred. Do you see this pink cloud as being one worldwide, so 10 worldwide routers for the BGP core, or do you see it as one in Europe, one in each continent?
The pink cloud is a very good question. It's what we're calling the internetwork. And whether the internetwork would be worldwide or somehow subdivided into regions, whether it would be partitioned so that you can only reach some RLOCs from it, that's all up in the air right now. I think what the Frequentis guys have been thinking, and I'm going to go check this with them when I go to the next ICAO meeting, is that pink cloud would be one worldwide, completely open, everybody can reach everybody network. But we know in reality, you're going to have regional partitionings. So we've got to find out what that's going to be, and that's one of the big to-dos in the group right now.
Yeah, because there's a lot of flights that don't cut across.
Right.
You could keep things compartmentalized.
Kind of compartmentalized and regionalized. Yeah.
But that should make the scaling easier, not harder. And if we think the scaling's okay anyway.
Yeah, but the thing that I'm concerned about is that if say the ETR over here wants to talk to an ITR over here, and the network is somehow partitioned, it might not be able to get those packets through the partitions. There might be a firewall or some kind of air gap that keeps that from happening. Yeah, but I'm more concerned about regional partitioning. Like the FAA has their own network, Eurocontrol has their own network, the Chinese system has their own network. What if you want to cut across those regions and you can't do it? That's where we need to do some more work.
We have this, we call it divided Argos, or contiguous Argos, disjoint Argos.
Oh, okay, yeah, that makes sense.
So there's this is a very interesting use case for something like this.
There is also some work in University Pierre Marie Curie in France about how to make different mapping systems to talk to each other. not specifically DDT. It's generally in a generic way how to share information so that we can make different mapping system interactive, so which comes to the fact that you split this pink cloud in several regions and several mapping systems.
So it kind of glues those regions together then.
They don't remember the detail, but they are able to request information in a certain way and withdraw. So there is a specific request that goes in a different mapping system. They just need to know that there is a different mapping system.
Right.
As it's happening.
Okay.
I can send you a pointer.
Yeah, I'd like that. Thank you.
Just one clarification question. So the last time I had a conversation with these guys was about that they're running into trouble replacing all their ISDN lines, and the problem for them was that they have to run dual active or in the financial industry it's called live transmission. So my ask is like, why this is not a multicast cloud do live feeds like we're doing in the financial industry, because their biggest concern was about that they have to deliver live for the applications, which means you always have to have two streams going over different paths. So the question is this is not applicable for this one, or don't we no longer care about live? Or?
So we do care about multicast, if that's what you're asking.
No, so this was my proposal, because, but they asked for live feeds over different paths, which is currently done, at least in the private cloud, with different ISDN links. But ISDN is going away, so the problem was, what should we do next? They say, hey, why not do multicast, which is the proper way. But they told me this will take 10 to 20 years to change the applications. They are doing multicast.
Right.
But here, this looks like a unicast network. But if the requirement is multicast to get live, maybe we have to think about it a different way.
Yeah, I was going to give you an example how you could do that to enforce this point. You could use predictive RLOCs and have two RLOCs, one for LDAX and one for VHF, for instance. And when the unicast packet gets sent, it's replicated to both of those RLOCs in each of the networks. Yeah. And if it's TCP, it just drops one because it's a duplicate. But when one of the links go down, there won't be duplicates.
In fact, the guys from Airbus proposed that very same thing at the ICAO meeting last time. They call it replication, which is what we've talked about here too.
Yeah.
So.
Between IBGP, are you using GU as the data plane?
We're we can use anything.
Or any, you didn't say which one, but using encapsulation between IBGP.
Using encapsulation.
You can go across the core routers.
Right. And it's likely to be an IP and UDP encapsulation of some kind, and there might be like a Lisp shim header too.
Yeah, I suggest UDP because you'll get better load balancing out of your core.
I think you're right.
Excellent. I think we are over. So, thank you very much. Unless there is any final question or comment you want to raise, not specifically to the Fred presentation, I guess we are done. So we will meet next time in Singapore, 2 months.
Clean now and please.
Okay, and enjoy the rest of the week at the IETF Empire.
The Lisp chat is holding up one side, and then we need to finish the intro and the discipline 30, finish 30, those are the most important things. Yeah. No, that's why I asked. Oh, okay. And please move. Sooner the better. I'd not rather be bombarding my APs with, we finished this. I've never known ladies complain about being told to finish too many things. Because it's not that important. Yes. Thank you. And thank you, Padma.